Java is an object-oriented programming language. That means all memory-based artifacts in Java are considered objects. Along with primitive data types such as integer, long, double, float, and short, you can create classes, which you can use as your own data type. For example, you can create a circle data type, a box data type, a person data type, a vehicle data type, and practically whatnot. I mean, whatnot cannot be a data type, or can it? Let us talk about classes and objects. Hi, I'm Dr. Shahriar Hossain. You are watching one of the videos of our Java programming language lecture series on computingforall.com. Today, we will talk about classes and objects in Java. You can consider a class as the definition of something. An object is an instance of a class. For example, a person is a class. A person may have properties like name, address, and date of birth. In addition, a person may have abilities such as writing essays, writing poems, solving math problems, and many more. Another person may have different values of the properties. For example, the other person might have a different name, a different address, and a different date of birth. The other person might write a different essay, write different poems, solve math problems, and many more. The concept person, which has properties and abilities, may have many instances. Each instance is an individual. In Java, a class is analogous to the concept person, and an object is analogous to an individual in this example. Similarly, we can create a class called circle. Can you tell me what properties a circle should have? If you are thinking about radius, diameter, circumference, area, all these items related to a circle, then you are correct. To define a circle, we actually do not need anything more than the radius, because we can generate the diameter, the circumference, and the area. What are the abilities of a circle? If we know the radius, a circle class can give us an idea about the area occupied. It can give us an idea about the diameter as well as the circumference. Given the circle class, we can create as many circle instances as we want. Each instance must have a radius based on the definition. Each instance must be capable of letting us know the area, the diameter, and the circumference. Again, a class has properties such as radius in the circle example. This is actually the data. Different circle instances might have different data. The abilities that a class has, such as informing us about the area of the circle, or the circumference of the circle, or the diameter of the circle, they are known as behaviors of that class. The data and the behaviors are composed in one object. The data part is designed by variables in a class. The behaviors are coded using methods in Java. Let us take a look at a Java program with more details. In the code, we will create a circle class. The circle class will have one data variable called radius. In the code, we will not deal with the diameter and circumference, but we will work with the area. We will generate two circle objects. When you started your programming lessons or programming exercises, first you actually started with creating a class. For example, you have class name, my test. This is the name of the class. Then inside this class, you can write multiple methods, and you are already familiar with methods. So this my test is a class, but this is a class that we have written casually. Our target was the main method. Our target was not the creation of multiple classes or objects. We really did not create any object out of this. This object-oriented paradigm, it comes from the fact that you can create your own variable type. You are familiar with integers, you are familiar with double, you are familiar with long integers, familiar with short integers, you are familiar with all primitive data types. In object-oriented programming, you can create your own data type. Today, we'll be creating our own data type. Let's say that I want to create a data type named circle. I have created a file named circle.java. Inside this, I will say what a circle data type should have. This is the circle file. I'm going to declare this new data type named circle, right? So for this new data type, all we have to do is we have to create a class named circle, and I already named the file as circle.java. 99% of the times you'll see that we write each class in a separate Java file. But you can write multiple classes in one Java file. But a common practice is to write one class in one file, and the class name circle should be the prefix of the file name. My class name is circle and my file name is circle.java. It's case sensitive, so C is capital in my file name, so it should be capital here too. To define a circle, we need a radius. Okay. If we know the radius, we can compute everything else. We can compute the diameter because that is twice the radius. We can compute the circumference because that is 2 times pi times r. The only variable we need is the radius. What we'll do is we'll create a radius. And to create a radius, let's say it's a double radius. That means we can store decimal points. And let's name it as this one. We have written our class here, our own data type here, inside which we have one variable. Note that I have written radius as the variable name. The spell of radius is radius. It does not have any O, but it does not matter. If you write an incorrectly spelled word as your variable name, all we have to make sure is that we use the incorrectly spelled variable name consistently whenever access to this specific variable is required. Okay, it's a circle class, so you'd need only one variable. If it were a rectangle class, for a rectangle class, how many variables do you need? If your answer is two variables, then you are correct. For a rectangle, we need two dimensions, length and width. But for a circle class, okay, we prefer just one variable for now. Rest of the things like area, circumference, all those things are directly dependent on radius. So we are not going to store them in a variable, we'll compute them on the fly. Basically, this is my class at this point. Let's see if that is true. If that is true, this is my circle class. Okay, just like I declare my integers like integer I equals 10, just like I declare my integers like that, I'll be declaring my first circle object variable using similar format. So when we declare a variable, at first we say the data type. Here I is of integer data type, so we mentioned the data type. So what I'm going to do is I'm going to say that, okay, my data type is circle. And I have already provided the definition of circle. That means this class circle is my data type. So I'm saying circle is my data type, and my variable name is C1. If I put semicolon here, it's the correct syntax. But when you say C1, basically it's not given any home. That means it does not have any address. In another sense, in technical language, it is called C1 is currently pointing to null. Syntax-wise, this entire program is correct. Let me show you that this is correct. I'm compiling this. In the directory, you notice that you have circle.java. You have mytest.java. Mytest.java contains a code that has a reference to circle class, and that circle class is present in circle.java. The moment Java compiler will start looking at this main method, it will see I, okay, I know what this I is. This is integer. Java knows about primitive data types. Now I'm saying circle C1. When I'm saying circle C1, then the compiler will think, oh, well, I don't know what a circle is. I never saw it before. What it will do is it will search for any circle.java file that exists with mytest.java, because you are running mytest.java and it has come across an unknown, which is circle data type, an unknown data type. So it will search for circle.java and it will find circle.java and it will go inside circle.java and it will see that the class is not created because it has to create the class to read it. So it will automatically compile circle.java. If we compile mytest.java, of course, mytest.class will be generated, but at the same time, circle.class will be generated. That is because mytest.java contains a reference to circle.java. See, there is no compilation error, so my code is correct. And notice here that circle.class has been generated. Although I only compiled mytest.java, of course, my test.class is generated, but at the same time, circle.class is also generated. This is a too simple code. It does not have much use. We did not even print anything. Let us try to print something. Let us try to print C1 and see what happens. Unfortunately, C1 is not yet initialized in this code. Therefore, we cannot really print it. For initializing C1, we need to create a circle object. To create an instance or an object of a class, we need to use the new syntax. You are familiar with the syntax new because you worked with arrays. For a single dimensional array, you said something like integer one-dimensional array nums equals new integer, let's say 10. So this new syntax was actually creating a new object, which is an integer array object. Similar to that, you have to create a new object, but here it's a circle object. So you will say circle, and you will have to provide this parenthesis here. This is called a constructor. Okay, the constructor will create an address location for this circle object. So this new is analogous to this new in an integer array, but unlike an integer array where you provided this syntax, now you are saying that, okay, this is my data type called circle, and construct it using the constructor. Again, we'll talk about what constructor is pretty soon. I have compiled my test and run the program. I see this output. Note that I printed C1. In place of C1, this text is printed. This text is actually a representation of the address location of C1. Let us discuss about it more. We printed C1. C1 is an object inside which you have a variable named radius. But we are printing the object. Let's say if I want to print a house, basically the house is not printed. The address of the house is printed. So this C1 is an object. Not really. It's a reference to a new object. And a reference is nothing but an address. So when you are printing C1, Practically, you are printing an object reference, an object address, and see circle at the rate 15DB9742. That is the address location of that object. Now, if you want to really access a variable that is written inside this class, you have the access using a dot operator. That means if you say C1 dot, then if you provide the variable name, which is radius, you will be printing the radius. Okay, and let's see what radius it prints. So let me compile it. Let me run it and see the radius of the object you have just created, C1. The radius is C1 dot radius is actually 0, although you did not initialize it. Okay, so in any class, if you put any global variables like this one, radius, it's not inside any method of this class. It's just outside any method. It's in the public area. So if you use variables like this, they're automatically initialized to 0. All the numeric values will be automatically initialized to 0. That's why you have a 0 here. Okay, when you print it, you have a 0 here. But you could say, oh, okay, in the very beginning, I have created my object C1. Now I want to change radius to 20.89. Okay, so C1 dot radius is initialized to 20.89. If you compile it, if you run it, you have 20.89. Okay, so in C1 you have 20.89. What I'm going to do is I'm going to create another circle object named C2. Inside C2, I'll be putting another radius, let's say 30.01. If I want to print C2, okay, C2 dot radius, so C1 dot radius will contain 20.89, but C2 dot radius will contain 30.01. Okay, again, to access the variable inside the object, you need the dot operator. C1 and C2 are two different instances of this circle class. The variable name radius inside them is the same, but they are two different variables in two different circle objects. Okay. I will take this system.out.println statement for c1.radius here just to make the code neater. In mytest.java, we created the circle object c1 and we initialized its radius variable. Then we created the second circle object c2 and we also initialized the radius variable of c2. We printed the radius variable of C1, then we printed the radius variable of C2. Compile mytest.java and run it. We see that the radii 20.89 and 30.01 of the two circle objects are printed on the terminal. That is, the radius variable in two circle objects is actually two variables with the same name. For example, you have integer I equals 10. You could create another integer j equals 20. Or you could create another integer k equals with the same value as the first one. But this variable k and this variable I, they're different actually. They are different tens. Similarly, C1 is one variable, one object. C2 is another variable, another object. These are two different circle objects. The two circle objects may or may not have different radius values. We can write any number of methods in a class. Let us write a method that will return us the area of the circle for the radius value stored in this radius variable. I am writing the method public double get area. The method will return the computed area of a circle. The computed area will be a double precision number. Therefore, the return type is double. In the parenthesis, we do not need any parameter because we will compute the area of a circle for which we only need the radius. The radius of the circle is already stored in the radius variable, which is accessible from any method of this circle class. The area of a circle is pi times radius square. I am writing a variable named area for which I am computing pi times radius. Note that the pi value is already available with Java as math.pi. We have computed the area. Now all we have to do is to return the area. So whatever object you are in that object you have a radius. If you just say that object dot get area, then your execution will come here in this method. After coming here, you'll compute area, which is math.py times radius of this particular object times radius of this particular object, and then return area. Okay, so this method will give us the area. Okay, so now I'm writing radius. At the same time, I'm writing area equals, I'm going to say C1 dot get area. Does get area have any parameter? No. So I'm going to keep it empty. Again, to access any public variable like radius or to access any public method like getArea, we have to say the variable name or the object variable dot. Okay, the dot operator will give you access to that particular method or to that particular variable if that variable or the method is public. I want to print the area of the second circle I have as well. Here this is C2. Okay, so this radius of C1 will be printed and the area will be printed. So let's see. So I'm compiling it. So what will happen now? Basically 20.89 will be printed, then the area will be printed, then 30.01 will be printed, then the area will be printed. This is the area of the first circle C1, which has a radius of this. This is the area of the second circle, which is C2, which has a radius of this one. C1 dot radius gave us the radius of object C1. C1.getArea gave us the area occupied by the circle of that certain radius. Also, C2.radius gave us the radius of the circle object C2, and C2.getArea gave us the area occupied by the circle of that radius. The variable radius and the method getArea are designed by us in the circle class. We said that radius it's a variable inside my circle, and that radius variable is practically my data that this circle object should contain. And this getArea is basically not data, because once you execute it, you are not storing the area anywhere. In this circle class, you are not storing it. In the circle object, you are just calculating this. This method is called the behavior. So the variable is basically the data. Any method here inside a class is basically to control the behavior of this particular circle. Now, you might say that, okay, this radius is something that I don't want to directly allow programmers to access from here. In my test, you have created two objects. One is C1 and the other one is C2. And each of these objects will have a circle instance. So in a circle instance, you have radius. Okay, you have radius, and radius is equal to, for C1, 20.89. Okay. For C2, it also has a radius variable, okay, which is 30.01. C1 has a method named getArea. Also, C2 has a method named getArea. Here you have said area equals pi times radius square. But here for C1, you have radius 20.89 square. So you are returning that area. Here in C2, you have the same code, but the area is different because the radius is different. In C2, the area is pi times 30.01 times 30.01. So when you are returning area, you are basically returning this value. If we come to the code, this C1 dot get area will actually come here. C1 has a radius of 20.89. So get area will return me pi times 20.89 times 20.89. So that will be area. And then I'll be returning that. So when you return that, your execution is returned here with the value of that area. So C1 dot get area will be that particular returned value, the value you have returned from the get area method of C1. So C1 has a get area method, C2 has a get area method. That is how you defined your circle class. Here we are printing these two items. Okay. So now what happens if we say that this radius is a private variable? When you don't say anything for a variable, it's considered public in the current directory. So any class from the current directory, such as my test is also in the current directory as circle.java. So my test can see what this is. But if you say private, then my test will not be able to see radius anymore. So here when you said c1.radius equal 20.89, here actually the compiler will throw an error, say that nope, cannot access radius, it's private. So let's see. Java C, when we are trying to compile, it is saying no, radius has private access in circle. So this particular dot operator, it's not true that it gives us access to all the variables and all the methods. Actually, this dot operator gives us access to only the public variables and the public methods. So this is a public method, getArea. That's why we can use dot getArea. But now this variable is not public, it's private. We explicitly mentioned that. So now what we can do is we can write a public method to set radius, which is of void return type, which takes one double parameter. We can say, okay, our variable radius should be equal to this parameter variable red. Now notice that this set radius is a public method, just like getArea. Its access is public, meaning is that now what we can do is, instead of directly accessing the variable, we can say c1 dot set radius, and set radius is a method. Once we give that parameter, it comes here. The parameter is copied to our private variable. We are creating our circles, but via the set radius method, because we do not have direct access to the variable. C2 dot radius is 30 point something. So now if we compile and then if we run it, then we have the area just like before. Now notice that in this method, from outside this method, we can never know what this radius variable is. Okay, of course, we just sent it here. That's why we know it. But when your execution comes here, if you want to know from my test what the radius is, what should we do? Because the radius is private, we can write another public method which will return us a double because we want to know what the radius is, and we'll try to get the radius, which does not have any parameter because it will just return the radius, nothing else. Now what we can do is, for every object, if we say get radius, something like this, if we say c1 dot get radius, basically we are getting our radius from c1 object. So c2 dot get radius, we will get our object from c2. So now if we print again, we'll see that we have our radius 20.89 and 30.01. So sometimes you want to hide variables from direct access, rather you want to use a method, because let's say that this is a social security number. Inside get social security, probably you will write code like what is your password. You will write some sort of authentication code here. If the authentication succeeds, then you will return the social security number. Probably that can be a situation in banking software or many other software pieces. I have not yet explained what this set of parentheses is about. This is actually a part of a constructor. I will explain constructors in another video. I hope you found this lecture useful. We will talk more about Java classes and objects in the upcoming videos of our Java programming language lecture series. Subscribe to this channel to make sure that you receive a notification when we post any new video. Happy programming and have a wonderful time.